Welcome, 5 chemistry students, to lesson 2 of the heat chapter. Okay, I just brought up our PowerPoint. So in this section, we'll be looking at the concepts of delta T, a change in temperature, and delta H, a change in enthalpy. We'll redefine enthalpy. But the important thing is we need to understand that whenever we calculate the delta or change in a numerical value, we always use the final value minus the initial value. And it's important to put them in the right order because that gives you the correct sign, positive or negative, for the change. So let's look at an example. If this morning the outdoor temperature was 45, and now it's 60 degrees in the afternoon, what is the delta T, or change in temperature? So TF means T final, TI means T initial. So it is now 60, it was 45. The delta T is plus 15. Temperature increased, delta T is positive, and we tend to think that when things increase, it's positive. If your bank account increases, it's positive. Another example, let's say the temperature outside this afternoon is 70 degrees, and then it drops to 50 degrees in the afternoon. Calculate the delta T. Well, the final temperature is 50 minus the initial temperature of 70 gives us a temperature of minus 20. Temperature has decreased, delta T is negative. So negative, we tend to think of a decrease as negative. If my bank account decreases, it is negative. So when calculating delta T, delta H, delta anything, the sign, plus or minus, is very important. Enthalpy is the energy content of a system, and it's designated by the symbol H. Energy content can also be thought of as the stored chemical energy. Enthalpy change is the heat absorbed or released during a reaction. What is the change from chemical energy to heat, or heat to chemical energy? Again, if we are going to look at a delta or change, it's final minus initial. The products in a reaction exist finally. The reactants existed initially. So products minus reactants represents final minus initial. So if delta H is positive, heat is absorbed, and we say that the reaction is endothermic. Heat was transformed into chemical energy. If delta H is negative, heat was released, chemical energy was changed into heat. It is an exothermic reaction. Now, when we associate delta H with a chemical reaction, we can write it either as a delta H after the reaction, or we can also include it in the reaction as a reactant or product. So here's what that looks like. Combustion is exothermic. When we burn something, heat is released, and it is a product of the reaction. So if I want to include it, I would put it on the product side, along with the products, carbon dioxide and water. So really, a plus sign in an equation means and. When C2H6 is burned in the presence of oxygen, CO2 and H2O and so many kilojoules of heat are produced. The other way to write it is to simply write the chemical equation and then include the delta H after it. When we say delta H equals, it is important to say, is it negative or is it positive? We don't write minus 2859 in the equation because it really means and. But when I'm quoting delta H separately, it is important to write either negative or positive. So here's an example of an endothermic reaction. The reaction between sodium bicarbonate and hydrochloric acid requires heat energy to occur. So it is a reactant. It gets used up just like the other reactants get used up. So when I react sodium bicarbonate with hydrochloric acid, it uses up a certain amount of heat to create the NaCl, H2O, and CO2. The final, so when we write it in the equation, we would put it on the left with the reactants. If I write it separately as delta H, the final stored energy is higher than the initial stored energy. So delta H is positive 572 kilojoules. Okay, today's lesson is very short. The only thing I am requiring from you today is the 100% completion of the questions on this Edpuzzle. If you are actually paying attention to the presentation, I try not to make the questions difficult. So please pay attention the first time and then you won't have to do it again. Okay, that's all for today. I will touch base with you again tomorrow. Thank you.